Hi friends, in the first two examples we have studied, there was only voltage sources. Now we will see some examples which is having current sources also. Mesh analysis with a current source. So we have studied that if the current source is in parallel with the source resistance, we can convert the current source to voltage source with the Ohm's law. That is, in both this source resistance will remain the same, while this voltage V is equal to Is into Rs. That is, voltage is equal to I into R, while this source resistance remains the same. If the resistance is in series with the current source, we can neglect it. If there is a current source in a circuit, there are two possibilities. The first possibility is current source is present in any branch of a mesh which is not shared by other branches in the network. See here, this 2 milliampere current source is there, which is in this branch of mesh 1, but this current source is not shared by either mesh 2 or mesh 3. Similarly, here is also a current source that is in mesh 2, but this is not shared by either mesh 1 or mesh 3. So, current in this mesh, that is, if it is I1, then that I1 is equal to this 2 milliampere. Similarly, here, if that current is I2, I2 is equal to 4 milliampere. The second possibility is that current source will be common between two meshes. See here, let this is mesh 1, mesh 2, this is mesh 3. This current is shared by this mesh 1 and mesh 2. That is, both meshes 1 and 2 are sharing the same current source along a resistance in series with it. In such a case, we will be avoiding this current source temporarily and we will apply mesh analysis. So the circuit becomes like this. So in this case, as there is no voltage drop or voltage source in that branch, we will temporarily remove that branch as this figure, and we can draw a loop containing mesh 1 and 2. That is, earlier here it was mesh current 1 I1, here it was mesh current I2, and here it was mesh current I3. Now mesh 1 and mesh 2 are merged together and we will draw a loop containing mesh 1 and mesh 2. This is called a super mesh. In example 3, we are asked to find the branch currents Ix and Iy in the circuit shown. See here, there is a voltage source of 100 volt, while here is a current source. As there is a resistance in parallel with this 8 ampere current source, we can convert it into a equivalent voltage source. Earlier we have studied that a voltage source can be converted to current source and a current source can be converted to voltage source. Here, while converting this current source, these two resistances will be the same. Here our resistance is 10 ohm and this 8 ampere current, when it becomes a voltage source, it is I into R. So here the voltage source becomes 8 into 10, which is equal to 80 volt. So we can redraw this circuit as like this. See, this current source is converted to voltage source here. Now, as in the earlier examples, we will solve it using mesh analysis. For that, we will mark the, here 3 meshes are there. We will mark it as 1, 2 and 3. Then mesh current in 1 is I1, mesh current in 2 is I2 and mesh current in 3 is I3. Then taking the case of these resistances, see current I1 is in this direction. It is entering here, leaving here. So at entering point plus and leaving point minus. Similarly, in 4 ohm resistance, it is entering here and leaving here. For mesh 2, this I2 is entering here and leaving here, and in 3 ohm it is entering here plus and leaving point minus. For in this 4 ohm resistance, it is entering here and leaving at this point, so it is plus here and minus here. In mesh 3, in 10 ohm current is entering here and leaving here, so voltage drop is 10 into I3. In 5 ohm current is entering here plus and leaving here, that is minus. In 3 ohm current is entering here and leaving here. Next we will apply KVL for mesh 1, mesh 2 and mesh 3. Applying KVL for meshes 1, 2 and 3. For mesh 1, while starting from here, the voltage source, we are going in this direction minus to plus, so rise in potential, so it is 100. Then here plus to minus, that is voltage drop, that is minus 8 into I1. Voltage drop is I into R. In this resistance, current I1 is flowing from plus to minus. So minus 4 into, as we are in mesh 1, I1 will be written first, minus I2 is equal to 0. Or this can be written as 100 is equal to 8 I1 plus 4 into I1 minus I2. Then expanding and simplifying this one, 8 I1 plus 4 I1 minus 4 I2 is equal to 100. That is 8 I1 plus 4 I1 is 12 I1 minus 4 I2 is equal to 100. Dividing throughout by 4, 3 I1 minus I2 is equal to 25. That this is equation 1. Then for mesh 2, here I2 is flowing from positive to negative. So voltage drop is there, that is minus 2 I2. Here I2 is flowing from plus to minus. So minus 3 difference in I2 and I3 as they are in opposite direction. So as we are in mesh 2, we have to write I2 first, I2 minus I3. Then here in 4 ohm resistance, I2 is flowing from plus to minus. So minus 4 into current is difference between I2 and I1 as they are in opposite direction. As we are in mesh 2, we have to write I2 first minus I1. So the algebraic sum is equal to 0. Expanding this and simplifying, minus 2I2 minus 3I2 plus 3I3 minus 4I2 plus 4I1 is equal to 0. This can be rewritten as, here this 4I1, then minus 2I2 minus 3I2 and minus 4I2 can be added, and it gives minus 9I2 plus 3I3 is equal to 0, which is equation 2. Similarly for mesh 3, as in 80 volt, the mesh current is from plus to minus, fall in voltage is there. So we will write minus 80, then voltage drop in 10 ohm is plus to minus minus 10 I3. Then here also voltage drop is minus 5 into I3. Then here plus to minus, so minus 3 in 3 ohm. I3 is going upwards clockwise direction while I2 is in opposite direction. So current in 3 ohm is difference between I2 and I3. As we are in loop 3, we will write I3 first minus I2, which is equal to 0. Expanding and simplifying, we will get minus 80 minus 10 I3 minus 5 I3 minus 3 I3 plus 3 I2 is equal to 0. This can be written as 3 I2, then this minus 10 I3 minus 5 I3 and minus 3 I3 can be added. So it becomes minus 18 I3 is equal to, we can bring this minus 80 to right hand side and it becomes 80, which is equation number 3. Solving equations 1, 2 and 3, we will get I1 is equal to 8.72, I2 is equal to 2.79 ampere and I3 is equal to minus 3.98 ampere. As we are asked to find Ix and Iy, see Ix is the branch current through 2 ohm, which is the same as I2. So we can write Ix is equal to I2, which is this 2.79 ampere. Iy is equal to loop current I2 minus I3, that is I2 is 2.79 minus I3, we got it as minus 3.98, that is equal to 2.79 plus 3.98, which is equal to 6.77 ampere. In this example, we are asked to find the current I0 using mesh current analysis. See here, as we have done earlier, first of all, we will mark the 3 meshes. Let this is mesh 1, mesh 2 and this is mesh 3, and the current flowing in mesh 1 is I1, current in mesh 2 is I2 and the current in mesh 3 is I3. Earlier we have studied that in this mesh current I1 is same as the branch current which is passing here. So I1 is equal to 2 milliampere. So we can straight away write I1 is equal to 2 milliampere. That is equal to 2 into 10 raised to minus 3 ampere. Similarly, in mesh 2, I2 is the current flowing through this branch, which is 4 milliampere. So I2 is equal to 4 milliampere. I2 is equal to 4 milliampere, which is the current flowing through this branch. That is equal to 4 into 10 raised to minus 3 ampere. Applying KVL in mesh 3, in 1K, we will mark the polarities. Here as current is flowing in this way, here it will be plus and here it will be minus. In this one, as current is flowing in this way, here it is plus and this is minus. In 1K, I3 is flowing in this way while I1 is flowing in the opposite direction. That is, voltage drop in 1K is minus 1K into I3 minus I1. Then here fall in potential is there, plus to minus, so minus 8 volt. Then here plus to minus, that is voltage drop, minus 2K into I3 is in this direction and I2 is in the opposite direction. So difference will be there. As we are in mesh 3, I3 is to be written first. I3 minus I2 is equal to 0. Expanding and simplifying, minus 10 raised to 3. 1K is 10 raised to 3. I3 plus 10 raised to 3. I1 minus 8 minus 2 into 10 raised to 3. I3 plus 2 into 10 raised to 3. I2 is equal to 0. But we know that I1 is 2 into 10 raised to minus 3 and I2 is 4 into 10 raised to minus 3. Applying here, minus 10 raised to 3 I3 plus 10 raised to 3 into I1, that is 2 into 10 raised to minus 3 minus 8 minus 2 into 10 raised to 3 I3 plus 2 into 10 raised to 3 I2 is 4 into 10 raised to minus 3. This is equal to 0. See here, 10 raised to 3 and 10 raised to minus 3 can be cancelled. Similarly, here this 10 raised to 3 and 10 raised to minus 3 can be cancelled. Rewriting, here is I3, here also is I3. So this becomes minus 3 into 10 raised to 3 I3 plus 2 minus 8 plus 2 into 4. 8 is equal to 0. This plus 8 and minus 8 can be cancelled and this 2 goes to right hand side. Therefore, minus 3 into 10 raised to 3 I3 is equal to minus 2, or 3 into 10 raised to 3 I3 is equal to 2. Therefore, I3 is 2 divided by 3 into 10 raised to 3, which is equal to 2 by 3 is 0.67 into 1 by 10 raised to 3, that is equal to 0.67 milliampere. Here in this branch, I0 is the difference between I2 and I3. I0 is equal to I2 minus I3, that is equal to 4 milliampere minus 0.67 milliampere, which is equal to 3.33 milliampere. Here we are asked to find the voltage drop in the 6 ohm resistance in the given figure using mesh current analysis. Earlier we have discussed about current source which is sharing two meshes. See, in this case, this current source is sharing this mesh as well as this mesh. In this case, as there is no voltage drop or voltage source in this branch, we will temporarily remove that branch as in this figure, so that we can draw mesh 1 and mesh 2 like this, avoiding this branch. Here mesh 1 and mesh 2 are merged together. We will first of all mark the meshes 1, 2 and 3. Current flowing through mesh 1 is I1, through mesh 2 is I2 and through mesh 3 I3. See here, this current source is shared by mesh 1 as well as mesh 2. So temporarily we will be withdrawing as we have said earlier. So we can redraw this figure as like this. This mesh 1, 2, 3 and mesh currents are I1, I2 and I3. Now we will form a super mesh with 1 and 2 like this. Now applying Kirchhoff's voltage law to mesh 1 and mesh 2, which is combined together to form a super mesh. Here current is flowing from minus to plus. Rise in voltage, that is plus 9, then comes here. Here while entering it is positive, leaving negative. So this here it is voltage drop 5 into I2 minus 5 into I2 as it is voltage drop. Current is entering here and leaving here. So minus 10, and as we are in mesh 2, we will write the current as I2 minus I3 minus, then coming here, this super mesh current flow is like this. It is entering here, leaving here. So here also voltage drop, that is minus 3 I1 minus I3, which is equal to 0. Expanding and simplifying it, we will get 9 minus 5 I2 minus 10 I2 plus 10 I3 minus 3 I1 plus 3 I3 is equal to 0. Rewriting minus 3 I1, then minus 5 I2 and minus 10 I2 gives minus 15 I2, then comes 10 I3 and 3 I3, which is plus 13 I3 is equal to, we can bring that 9 to right hand side so that it is minus 9, or 3 I1 plus 15 I2 minus 13 I3 is equal to 9. Let this is equation 1. And for mesh 3, in 6 ohm, current is in clockwise direction. It is entering here, leaving here. In 3 ohm, current is entering here, leaving here. And in 10 ohm, current is entering here, leaving here. So in 6 ohm, voltage drop is there. So minus 6 I3 minus, here also voltage drop is there. So minus 3 into I3 minus I1, as we are in mesh 3. 3 into I3 minus I1. Next is the drop in 10 ohm, plus to minus. So minus 10, as we are in mesh 3, I3 minus I2 is equal to 0. Expanding, minus 6 I3 minus 3 I3 plus 3 I1 minus 10 I3 plus 10 I2 is equal to 0. Simplifying this equation, this 3 I1, next is 10 I2 minus, here I3 is minus 6 minus 3 and minus 10, that is minus 19 I3 is equal to 0, which is equation 2. Let this is node A. Applying Kirchhoff's current law, that is KCL at node A, we know that 1 ampere current is coming in this direction, while here I1 is coming, that is this mesh current, and here I2, this mesh current is leaving. So as per KCL, sum of currents entering at a point is equal to sum of currents leaving. So I1 plus 1 ampere is equal to I2. I1 plus 1 ampere is equal to I2. This can be written as I1 minus I2 is equal to minus 1. Let this is equation 3. So we have got 3 equations. 3 I1 plus 15 I2 minus 13 I3 is equal to 9, which is equation 1. Then 3 I1 plus 10 I2 minus 19 I3 is equal to 0, which is equation 2, and I1 minus I2 is equal to minus 1, which is equation 3. Solving these 3 equations, we will get I1 is equal to 0.09 ampere, I2 is equal to 1.09 ampere, and I3 is equal to 0.59 ampere. We are asked to find the voltage drop in the 6 ohm resistance. Through 6 ohm, current I3 is flowing, that is 0.59 ampere. So voltage drop in 6 ohm, voltage drop in 6 ohm resistance is V is equal to I into R, that is equal to I3 into 6 ohm, that is 0.59 into 6, which is equal to 3.54 volts. I think this class also might have been useful to you. If you found any difficulty in understanding any portions of this class, please refer to my previous classes, the links of which are given below. Thanks for watching my video. Please like it, share it and subscribe it by pressing that bell button. See you next time. Bye.